affects impact and reach? This is the fourth video in our series of videos on basic nozzle knowledge. This video covers impact and reach. And the impact a fluid has on a given target is very important for certain applications like cleaning. And reach is defined as how far we can project a given spray in a given direction. So clearly very important for getting the fluid to where we want it to go. Now they're obviously fairly closely related properties. It's affected by basically four key factors: the size of the nozzle, so the flow rate we've got going through the nozzle, the K factor that we covered in the video, the spray pattern type has a big effect on both, the spray angle has an effect, and the pressure at which we're spraying the fluid has an effect. Let's have a look at the nozzle size. Fairly obviously, basically, the bigger the nozzle, the bigger the K factor, the bigger the flow rate we're getting through there, the longer the reach, and higher the impact. It's a fairly straightforward relationship there. The spray pattern type is the next factor. This has an order. So solid stream nozzles will have the highest impact and reach for any given pressure and flow rate. Then flat fan nozzles will be next. And then hollow cone and full cone nozzles, it will depend on various factors in which order they come in, but they generally low reach and low impact. Next factor is the spray angle. Simple rule here again, the bigger the spray angle, the lower the reach and the impact. And we can think about this and the spray pattern type essentially in terms of the concentration of the fluid. If we're distributing the fluid over a bigger area with a wider spray angle or a full cone or flat fan pattern as opposed to a solid stream nozzle, we're distributing that energy over a further area, so obviously it's going to have less reach and less impact. The final factor is fluid pressure. Now this is slightly complex and slightly counterintuitive in some respects, and it depends on the type of nozzle that we're using. For solid stream nozzles, the higher the fluid delivery pressure, generally the higher the impact will be and the higher the reach will be. However, there is a limiting factor to this, because at a certain point the fluid velocity gets so high it starts to atomize, and that actually reduces the potential impact and reach. So there's a cut-off point depending on how well the nozzle is made as to how much that relationship holds true. For flat fan nozzles, that cut-off point is less. We still get more impact and more reach as we increase pressure early on, but as soon as it reaches a certain point, the fluid starts to atomize more and more, and we get no extra benefit, and in fact we get reduced benefit in terms of impact and reach, because we're atomizing that fluid rather than actually producing any impact. And that relationship is even more true for hollow cone and full cone nozzles. So generally speaking, with hollow and full cone nozzles, the higher the pressure, the less reach we have, particularly in windy conditions or in gas flows, because with full cone and hollow cone nozzles, as we increase the pressure, we start to atomize the fluid more and more. We get smaller and smaller drop sizes, and they cannot penetrate into even fairly slow gas flows and windy conditions. So we actually start to reduce impact and reduce reach, which can be quite counterintuitive, because the intuition is that if we increase pressure, we're going to increase impact and reach, and that isn't true for hollow and full cone nozzles, but it is true up to a certain point for solid stream and flat fan nozzles. That's our video on impact and reach. Hope you found it useful.